Hello everyone, I hope you all are doing great. I welcome you all to this interesting series on system design. So in this video, we will discuss about the production data redundancy and recovery. So before we move ahead, let's quickly understand what do we understand by data redundancy and recovery, and then we will dig deeper into this. So to understand this, let's take a simple example. So as we all know, in today's world, almost all the enterprise applications stores their data on the cloud, right? So on the cloud, let's take an example of AWS. So on the AWS, first we'll have a region, right? Let's take example of Mumbai region. So let's say we have this region like this. We have many regions on the AWS like Mumbai, Tokyo, or the North America, South America, right? There are different regions where the data can be stored. So here within the region, we'll have the availability zones. So within these availability zones, we'll be creating our database in either one availability zone or in multiple availability zone according to the requirement. So here, just to give a quick analogy, with a region, you can say that it's one building, and within that one building, we have multiple rooms that you can think of multiple availability zones. So that's exactly how physically the regions are divided. And similarly, we'll have different regions and their availability zones. So let's take example of Mumbai region. So let's say if the data, let's say our database is created in the first availability zone of the Mumbai. So now initially when this will be serving our application, but let's say due to some issue, let's say this database goes down. Now what happens? Because of this, our whole application comes down because there is no data to serve to our users. So to overcome this, what the first step we need to take is we should maintain another standby node or a replica database that is replicated from our primary database. So that can be in the same availability zone or in the different availability zones. Okay. So this is nothing but a replica of our or a standby node or a server of our database. So if the first database primary goes down, then we can redirect the traffic to the other primary or the standby nodes so that our application keeps serving to the user without any downtime. So this concept is called data redundancy, where keeping a standby database so that if the primary goes down, then also we can rely or switch on the secondary database and our application should keep serving without any downtime. And when this is done at different levels, so for example, right now we can implement redundancy in one availability zone or within different availability zones or in the different regions as well. So that even if this region goes down, we can redirect the traffic to the other region. So that can be decided according to the requirement of the application. Like for example, if our application is serving throughout the world, then definitely we should have the replica of the data in different regions. So that even if one region goes down, then our users should get served from the another region. So that's the concept of data redundancy. Next, we have the concept of data recovery. So data recovery is very simple. That is taking the regular backups of our data. So let's say if we have set 12 a.m. and 12 p.m. as the backup time every day, then that means we are taking the backup of our data twice a day. So that, for example, once we take a backup at 12 a.m. and within the next 12 hours, if at any time our data got corrupted, then we can just restore our data back from the last backup. So that's how we are able to recover our data and making sure that our users have almost all of their data. And then whatever the data got corrupted, we can just reply our database logs and try to get back the corrupted data if it is possible. But we are sure that at least till this point, our data is safe. So these are the two concepts, basic concepts that are implemented in the production systems at different layers so that the data is redundant and recoverable. Okay, so let's dig deeper on this. So here, that is the core idea, that is redundancy, as we discussed, keep the systems available. That is, if even our primary database goes down, our secondary database will keep serving the users. And backups and recovery restores the correctness. So when at some point of time, if the data got corrupted, then we can rely on our backup data so that we again start getting the correct data to serve our users. Next, here, the three problems every production system must solve. The first one is hardware failure. That is, even if one disk or even the whole region got crashed, then we should make sure that our users are served from some other region also. So that comes under the redundancy that we are solving using redundancy. Then we have data corruption. That is the second problem we need to solve. So to solve the data corruption issue, we need to take regular backups of the data, and we should store the point-in-time recovery logs. That is, the database, as we know, first keeps the logs of all the activities. So before saving any data or modifying any tables in the database, first it note downs that in the write ahead logs, and then the data is, then the modification is done on the tables. So those write ahead logs needs to be kept safely for a longer period of time, so that we can able to recover the data using those logs. And the next problem it needs to solve is a large disaster. That is, again, even one availability zone or one region goes down because of some war or some calamity, we should be able to serve from the other region. So these three major problems every system must solve. So that can be solved using 4-layer protections. The first one is local redundancy that we just now discussed, where within either one availability zone or in other availability zone, we should keep a standby database that is having the replica of the primary data, so that even if the primary goes down, we should rely on the secondary database. So that is a local redundancy. Next, database replication. So redundancy is considered from the physical server point of view or physical database point of view. Database replication is a process of how we replicate the data. So that comes under second layer, and here it can either be done using synchronously or asynchronously. So with synchronous data replication, the client has to wait until all the replicas gets the data. So when the primary will save the data, and primary will make sure that the other database also replicated with the same data, and only when the client will get the acknowledgement. But with asynchronous replication, the client do not has to wait for the replicas to get the data. Only the primary's acknowledgement is enough, but this reduces the latency. But with synchronous replication adds the latency to in the network. Okay, so that's the second layer of protection. Then the third layer comes the backup. As we discussed, we should keep taking up the backups at a regular interval according to the requirement. And then the fourth layer is the cross-region database or data replication that we already discussed. That is keeping the data in multiple regions, so that even if one region goes down, we should be relying on the other region. Next, in the database replication, that is the second layer. As we discussed, we have two options, that is synchronous and asynchronous, that we just discussed. And next, here we have the difference between redundancy, backup versus disaster recovery. So we have already discussed about this redundancy. What is redundancy? How it is different? Where the purpose is to reduce the downtime. Backups purpose is to recover the historical state of the data, and disaster recovery is to restore full service after the major incident. For example, wars or any natural calamity. So when such thing happens, we should be able to recover the whole data. So that's the difference here. And the next thing here we have is these two numbers that definitely defines the whole architecture. That is, the first one is RPO, that is recovery point objective. That is, we are defining how much data we can afford to lose. So for example, in the data recovery, we have set the 2 times in a day, that is a gap of 12 hours. Within that, that's the RPO here. That is the recovery point objective. So according to the requirement of the system, we can decide this number. Next, we have the recovery time objective. That is, once our system goes down, the database goes down, how much period of time we can wait until we restore that database. So that defines the recovery time objective. So these two numbers are decided according to the system's requirement, and that defines the database architecture. Okay, we'll discuss about I will show you all of these in the form of a simple demo at the end of this video. Next, we have the checkpoint logs and point-in-time recovery. So this is exactly what is done in case of data corruption. So when a data got corrupted at some point of time, first step will be to restore it using the backup, and whatever the period after the backup has been passed, that data is recovered using the logs. So how does that work? So as we know, whenever a data has to be persisted in a database, the database maintains the logs. I hope you all knowing that log, we call it as write ahead logs. So in this write ahead logs, it maintains, it writes every statement which has been executed on the database. So those statements will help us to get back the data. So that those logs are replayed and checked, at which point the data got corrupted, and before that everything is recovered. So that's regarding the logs and point-in-time recovery. Next, we have failover over restore. So failover here signifies that the server has physically failed, but the underlying data remains safe. So that can be recovered. But when compared to the restore, here the whole database got destroyed, but now that can be restored only through a backup that is present in another availability zone or in the another region. So that's the difference between failover and restore. Next, we have why one replica is not enough. Because when we just rely on one replica, in that case, an accidental delete statement, what will happen? It will delete both in the primary and in the replica. So that will impact the whole data. We'll not be able to recover it back. or any application bug writing bad data, that will impact again both the primary and replica, or the silent corruption. So to avoid these things, along with the replica, we should also rely on the backups at the regular intervals, and along with the backups, we should also make sure that the data is also present in the different region, so that we can able to recover it when some region goes down. So that's what is defined using a blast radius. So resiliency is not only about making copies, it's about making copies that cannot fail together, right? So blast radius is nothing but if all the copies share in the same region or in the same account or in the same network, then if that whole region goes down, then the whole data is gone. We cannot be able to recover it. That's the reason we should keep the data in another region that is in the outside of the blast radius, so that we should be able to recover it at the time of the disaster. Next, how the large scale system actually do this. So first, application writes to the primary database, then the primary replicates it to the standby database in another zone, availability zone, and then the read replicas exist for scaling and extra options, and automated snapshots, that is the backups taken regularly. Then this is very important, that is by transaction or the binary logs continuously archived. That is what I was talking about, that is write ahead logs. That will help us at the time of data corruption. Then the backups copy to another account or region, and recovery is tested regularly. So this is again a very important point, that is we may be taking the backups at regular interval of time, but if we have not tested it to recover, like if you have not tested to restore it to the at some point of time, then it's of no use, right? So regular testing of recovery of the backup is very important. So because a backup that has never been restored is only a theory, right? Next, here, what are the 5 common mistakes team makes? That is thinking the replication is backup. That is not, because backup is something that we can restore. Replication is where if the primary has corrupted data, then that will impact on the replication also, right? Next, taking backups but never testing the restore is again a mistake. We should regularly test the restoration, and keeping all copies in the same blast radius, that is within the same region, then again that's a very big mistake, because a region may go down at one point of time. So we should keep it in another region as well. Next, no transaction log or binary log retention. That's again a mistake. And not defining the RPO and RTO numbers. So that will be decided according to the requirement of the application. So these are the common mistakes the team makes that we should avoid. And finally, that's a final takeaway from this whole discussion about the recovery and redundancy and how it should be implemented. So now let's look at a simple demo of how we can implement redundancy and recovery. Okay, so let's look at a simple demo. So in this demo, we will take an example where we have created let's say we have created a database in the AWS, and then we look how redundancy is implemented over there. So let's say we have an AWS region. Just excuse me for this bad design diagrams. Okay, so let's say this is the Mumbai region, and in the Mumbai region, we have, let's say, created a database. So this is the initial setup we have did, and when we create it, it just get created in one of the availability zone in this region. But now after as our application grows and we feel that we should maintain the redundancy of our database, in that case when we enable that option, so now initially the AWS will make sure that a standby database gets created in another availability zone in the same region. Okay, so now the data transfer between the primary and this secondary database within the same availability zone happens through the synchronous communication. So as we already discussed about synchronous and asynchronous, so here if the secondary database or the replica is created in the same region in the different availability zone, then the data transfer happens synchronously. Okay, so for that reason, the moment the replica is created, it opens a TCP connection. It opens a persistent TCP connection with the primary database, and this persistent TCP connection is kept forever, and through that the data replication happens. So let's say how it is done. So basically here it will be having 2 threads. One is input output thread and one is a SQL thread. So those 2 threads helps to do this replication. So the moment data comes here, when it is first written in the logs, in the write ahead logs. Okay, let's say this is a write ahead log. So it will make sure that the write ahead log is updated, and the moment it gets updated, it will push an event to the replica. So the moment the event is pushed, it will push the data to the replica over this TCP connection, so that it will wait for the acknowledgement from the replica. So the first, the replica will take that data, it will persist into its database, the data gets persisted, and the moment it gets persisted, it will send back an acknowledgement, and only when the acknowledgement is received, the primary will persist the data and sends back the response to the client. So this happens synchronously. And why this option is enabled here, this option is chosen here because both are present in the same availability zone and the latency is very minimal. Okay, but now let's say after some time, let's say our application goes global. Okay, now we have global users. So in this case, we decided that the redundancy has to be implemented at a higher level. So for that reason, now if let's say we want our database to be present in another region as well. Okay, so let's say this is another region. Let's say it's North America. Okay, so now we want our database or a replica to be present over here. Now here comes the second way of communication, that is asynchronous. Because now let's say we have database over here. If we try to replicate the data in a synchronous manner as we are doing over here, then the latency will get increased. Then the response time of that API to the user gets increased. So that will create a bad user experience. So because of that reason, here again a persisted TCP connection is created. But in this case, the primary does fire and forget mechanism. So it will just fire a event to this replica that is present in another region. So it will take that event and it will update the data. But in this case, the primary will not wait for the acknowledgement from the replica present in another region. But that does not happen in the case of the replica present in the same region. Okay. So these are the two ways of communication through which the data replication happens, and with this we are making sure that our database is redundant by keeping a replica in different region and also in the different availability zone in the same region. So this is exactly what we will be looking at now in the demo. So this is what exactly we will be now looking at in the demo. Okay, so let's look at the demo. So in this demo, we will look into both the data redundancy and data recovery. So here we will try to mimic how it is exactly done in the AWS. So for that, we will take example of MySQL, that is the RDS. So here, first of all, I will run this setup.sh script. So this script will use this Docker Compose file to create 3 Docker containers. So each container will be having a MySQL server running in it. In that, the first container here will be our primary MySQL database server where all the writes and reads will be going. And this primary database will replicate the data into 2 replicas. The first replica is the in-sync replica. That is, the replication here happens synchronously with respect to the primary database. Because this replica database we will be creating in the same region in the different availability zone. Okay, so we discussed regarding this. Next, another replica here we will have in the different region. So because it's in the different region, here we will be going with the asynchronous process of replication. Okay, so that's how the overall architecture will look like. And so here, now let me run this command, that is the script setup.sh. Okay, so now this script has started. So this script will create the containers with the MySQL server running in it, and in the script itself I have configured it in such a way that post all these containers are created, it will automatically establish these TCP connections so that all the reads and writes happens between the replica and the primary database. Okay, so you can look into these scripts. I will be putting them into the GitHub repository. So for now we will not be going into what the script configuration is. You can look into that. So the purpose of this demo is to understand how the replication works. Okay, so our containers should be ready now. Okay, so we have one primary node, that is a primary MySQL server, and 2 replicas. Okay, so now let me start the demo. I'll run another script, that is demo.sh. Okay, so I have started demo.sh script. As you can see, it is giving an architecture overview where in our primary region we have the primary database and also another standby database that is present in another availability zone, that is AZ2. This is present in AZ1, and here the replication is in a synchronous manner. And another replica we have in the another region, here the replication is in asynchronous manner. Okay, so that's the primary database, primary architecture. Now let me also run the status script that will show us the live status of the databases. So for that, let me go to another terminal. So let me go inside MySQL replication demo. So here I need to run this script. So .venv, I'm activating the Python virtual environment, bin python3 status.py. Okay, so this will be monitoring the live status of the MySQL servers. So right now you can see all the three instances are healthy and each of them doesn't have any data right now. So let me go back to the terminal one, and now let me press enter and we'll implement the first phase. So in the first phase we are just writing the data to our primary database, and the primary database automatically replicating it to the other two replicas. So now if I go back to the status, you can see that all the three databases now have 10 rows. We just wrote to the primary has made sure that it writes to both the replicas. So now you can see the status. So let's go to the next step. So in the next step here, what we are doing, we are implementing async replication where it will lag behind. So for that reason, what we are doing, we are stopping the async replicas SQL thread. So in the initial discussion, as I said you, there will be two threads in every MySQL server. That is the first one. The first thread will be the SQL thread, and another thread will be the IO thread. So these two threads plays important role in both the data replication and writing the logs. So here we have stopped the SQL thread. Why? Because the moment the data is arrived from the primary to the one of the replica, the first input output thread comes into picture. So that input output thread, it will write the event into a log. Okay, so only when the event has been written to a log, then the SQL thread comes into picture and it will actually write that data to the database table. Okay, but now what we have did, from of the one of the replica, that is the async replica, we have stopped the SQL thread of that. Now because of that, what will happen, we will the replica will get the data, but it will be written only to the logs. It is not yet written into the table because the SQL thread is paused currently. Okay, so that is what we have done. So now if we go back to the status, you can see that the replica, the in-sync replica has got the extra 10 rows. Those are already written here, but the async replica is yet behind. It doesn't have the extra 8 rows which are written in the sync replica. So now I'll just press enter, and we will again resume the replica threads replicas SQL thread, and we'll wait for 2 seconds, and you will see that immediately in those 2 seconds the SQL thread is resumed, and it will write those logs into the table. So now if I go back, you can see that the async replica also got all the 18 rows. Okay, so this is how the replication works, and the replication difference between async and the synchronous. So you can read it over here. We can notice that sync replica is behind. Primary and sync replica are equal. Semi-sync ensured both committed together, but async replica buffered the events in relay logs but has not applied them yet. Okay, so when we pressed enter, we have resumed the async replica's SQL thread, and post that you can see that the async replica caught up, and this is exactly how AWS cross-region replication heal after a lag spike. Okay, so I hope you are able to understand how replication works within the same region, and when we have the replica in the another region. Okay, so that's what we wanted to know in this first demo of the redundancy. So this is nothing but a redundancy. Okay, so next look at data backup and recovery. So for that, let me run the next script, that is demo recovery.sh. Okay, so first we are checking whether all our servers are up and running or not. So all the 3 replication nodes are confirmed. Next, let me just press enter. So in the phase 1, we will understand why replication alone is not enough. That we have already discussed, where even if the replication is successful, but if the data got corrupted, then that gets impacted in the replicas as well. So we need a mechanism where we should be able to get the right data at some point of time. So for that, we need to implement the backup and recovery mechanism. So for that, let's see how we can do that. So for that, first of all, we need to define two things, that is RPO and RTO, that is recovery point objective, where we are defining how much data we can afford to lose. So using this, we will define at which interval we should take the backups and till which point we should have the logs. Okay, and next we have recovery time objective. So this tells how long can the system be down when there is some data corruption. Okay, so let's discuss these things. So now here in the phase 2, first of all, we'll implement the first thing, that is the taking the full backup. So for this, we are actually mimicking AWS RDS, automated daily snapshots plus bin log shipping to S3. So the backup consists of two parts. The first one is the MySQL tab, that is the whole backup of the data. So at every regular interval, we are taking the backups, and post taking the backup, let's say we have taken the backup at 2 a.m. in the morning, and the next backup is again at the same time the next day. So for the next 24 hours, we don't have the backup. So for that 24 hours, we need to maintain the bin logs, that is the write ahead logs, which will help us to get back the data if some disaster or some corruption happens during that 24 hours. Okay, so here first of all, you are taking the backup of the whole data at some point of time, and also taking the binary log files at every point or at every event of the database. So let's move to the next step here. So first of all, we are defining the RPO baseline. So here RPO stands for recovery objective, recovery point objective. So this is a timestamp where we are first of all taking the first backup, and now post this, we have also flushed the old binary logs. So here older binary logs are either archived or stored into some other place. Then binary log boundary is created. So now from this point of time, we are creating a new boundary, that is we are again taking the binary logs into a new file, so that post that time we should be able to quickly recover the data and running the MySQL dump, that is in DB consistent snapshot. So we have taken the snapshot, dump complete. So now for the first backup we have that is of size 3.7 MB. Next we have bin log anchor embedded in the dump. So from here now the bin logs will be collected for the next 24 hours if the next backup is after 24 hours. So 4 bin logs files archived, that these are the older bin logs. Okay, so this is the point we have established, that is the time. Next, let me just go to the next step. So now this is the point after taking the backup. So these are the next business days, all the events that happen there, where we can see there are multiple rows have been added to the database. So if we go back to the status, you can see that now the database has 28 rows. That is in the last 24 hours, we can say that next another 10 rows have been added to the database. So now these new 10 rows are not present in the backup, but they are present in the logs. So total 28 rows on all nodes. Post backup rows are 10 rows. Okay, so safe recovery point that we already recorded is this point. Okay, so here we have recorded it. So that is 1822. Okay, now the point in time recovery will stop replaying logs at this exact timestamp, because till this point we don't have any issues. So this is the safe recovery point recorded. So till this point all the logs we have are all safe, and whenever we reply we will be able to get the data till this point. Okay, so now let's go to the next phase, where we'll by intentionally we will do some data corruption, where we will delete a couple of rows from the database. So executing corruption on primary, corruption is executed. So waiting for 3 seconds. So during this time, the corruption get replicated into the primary, into the replication as well. So because of that, this is a core lesson that we are learning, that is the replication faithfully delivered the delete to the other replica that is present in the same availability zone. Async replica also applied it within seconds. So multi-region or multi-availability zones all are corrupted. So replication is availability insurance, not data correctness insurance. So I hope we got this first lesson here. So the time coordinates, the safe time that we have recorded. This is a safe time till which we have the event logs. So now we have two things for the recovery. The first one is the first backup that we have taken, and the second is this event log that we have taken in the next consecutive day. So till this point, will be able to recover the data. So let me just press enter. So in the phase 5, that is point in time recovery. Recovery plan is spin up a node recovery. A new node will spin up, and in this new node, first of all, we will pull the backup which we have already saved. So that will a fresh isolated container. So restore a full dump, so that will get all the data to the previous backup. Then copy the live binary logs from the primary, that is the and that will contains all the events post backup. So reply bin logs via MySQL bin log. So that will make sure we'll get back the data. So if I go here, right now we don't have the recovery node created. So now if I press enter, a recovery node will get created, and in that node we'll be able to get all the data back till or before the point of disaster. Okay, so it has been completed. Now if I go back to the status, you can see that a new node recovery has been created. We can also see that over here a new container has created, and in this new SQL server we have all the 18 rows that were there in the primary before the disaster. So this is how disaster the recovery, point in time recovery is implemented in the MySQL or in the AWS. So if we look at here, row counting, we got all the data back. And here if we look at RPO again, recovery point objective, how much data did we actually lose? So the backup was taken at this point of time, safe recovery was at this point of time, and corruption happened at this point. So actual data loss is 0 rows without bin logs. If we did not maintain the bin logs, then we would have lost 10 rows. But because we maintained that, so we were able to get the data back. So the dump alone gets the data till this point, okay? But bin logs reply gets you the data to the exact second before the bad event happened. So this is how AWS RDS point in time recovery works to the second. So RTO here is recovery time objective. So how long did recovery take? So it just took around 56 seconds. So that is the downtime we faced for our application to recover the whole data. So I hope you were able to understand the whole concept of how we need to implement the data redundancy and recovery plan for our production system. So all these three layers together helps us in creating the production grade data protection. Okay. So I hope you are able to get useful insights from this video. So let's meet in the next video.